Good morning. On your screen is a live view of Starship as it awaits its second attempt at our first ever integrated flight test from Starbase, Texas. If all goes well, we hope to see our Starship spacecraft and Super Heavy booster, which we collectively call Starship, lift off together for the first time in exactly 33 minutes from now. Thanks for tuning in. I'm Kate Tice, Quality Systems Engineering Manager here at SpaceX headquarters in Hawthorne, California.
And I'm Shiva Bharadwaj, a space operations engineer here at SpaceX. Now, if you've been following along, you'll know that we stood down from our initial launch attempt on Monday, and that was due to a frozen pressurization valve on the Super Heavy booster.
SpaceX teams investigated the issue and determined that this valve had some moisture in it, which caused the valve to freeze up when we were loading super chilled liquid oxygen into the booster.
Now, these valves are super important because we actually need a pressurant to go back into the tank as we consume propellant, and we actually use a pressurant that comes from the Raptor engines. It's heated down there and then put back in the tank. And so a frozen valve there would be a problem during the launch.
Yeah, and that's important. You can think of it like drinking out of a thin plastic water bottle. If you're chugging that water, it crinkles if you don't let air back into it. So we use that hot exhaust gas from the Raptor engines to refill that consumed volume as propellant is depleted. So it was a great find by the countdown, and that's why we have a countdown, is to allow us to find those issues prior to liftoff. So all of that being said, our teams learned a lot over the last 48 hours, and we are ready to give it another go. As many of you know, Starship is the latest and largest vehicle developed to date by SpaceX. It will be the world's most powerful launch vehicle once fully developed and have twice the thrust of the Saturn V rocket. But the key breakthrough with Starship is that it will be fully reusable and capable of carrying up to 150 metric tons of payload to orbit in a reusable configuration and up to 250 metric tons when expendable.
Now, for context, Falcon 9 is only partially reusable. We recovered the largest part of the rocket, that's called the first stage, but we don't recover the second stage. And Falcon 9's heaviest payload to date is just over 17 metric tons. So 150 to 250 metric tons on Starship is an order of magnitude greater in terms of the payload capacity. Now, for today's test, we will be the first of many as we work towards transitioning Starship from a developmental into an operational program. And the primary objective today is to gather as much data as we can around the fully integrated vehicle. Now, while we have flown the Starship spacecraft in the past, it is going to be the first attempt of Super Heavy and the first opportunity for us to validate how the two vehicles operate together.
We are so excited for this. The purposes for today's flight, we will consider any data received that helps inform and improve future builds of Starship as a success. From a milestone standpoint, our main goal is to clear the pad. Every milestone beyond that is a bonus. The further we fly, the more data we can collect.
Now, if it does all go well, then we'll expect the Super Heavy to light up its 33 Raptor engines at the base of the vehicle and lift off, clear the pad away down from Starbase, in Starbase, Texas. And then it'll go into ascent. About 3 minutes into its ascent, we're going to expect to see Super Heavy separate from the Starship. It'll perform a flip maneuver, and then it'll execute a boost back burn, and we're going to be targeting a hard landing in the Gulf of Mexico.
And while that's happening, we hope to see Starship's 6 second stage engines ignite and watch as Starship coasts for about an hour at altitudes ranging between 150 and 250 kilometers before re-entering Earth's atmosphere and make its own hard landing in the Pacific Ocean about 250-ish kilometers offshore. Now, we are not really expecting many camera views after separation. That is to say, if we even make it that far. But we do promise that whatever views we do have, we will bring them to you live.
Yep. We have a couple of ground stations along the way. So if we are able to get good telemetry, assuming we make it that far into the ascent, then of course those will be available on the stream. And also worth mentioning today, like the whole just getting the vehicle off the pad is a complex endeavor. We are going to be trying to reduce complexity by attempting those hard water landings instead of trying a normal landing like you're used to on Falcon 9.
Exactly. We are not attempting to recover these vehicles. So yeah, hard landings in store for both.
Now, in a little bit, we'll take a closer look at the vehicle and the launch pad. But first, the teams have been doing a tremendous amount of work over the last few months. In fact, there's a great shot of our Hawthorne team up here bright and early to watch the launch. Teams have been prepping really for the last few days, especially to try to get in today's launch attempt.
And here you can see a live view of the South Padre Amphitheater, where both SpaceX employees, friends and family, and members of the public are gathering to watch Starship lift off. And we can see the crowds are gathering there as well. And of course, we want to give a shout out to the SpaceX team. You see them there on screen, members of our our Star Command Center. That is our Starbase Launch Control Center.
Yep, those are the operators today who are going to be reviewing all the data and, of course, giving us the go, no-go poll, checking the status to try to get in today's launch attempt just around 27 minutes from now.
And one thing I do want to mention, I misspoke. It's not the South Padre Amphitheater. It's the Cameron County Amphitheater.
Now, the entire Starship structure on your screen is made from stainless steel. When it's stacked, it stands about 120 meters tall. It's about 9 meters around. And we have this awesome video that shows you just how big that is. You can see one of our technicians there doing some final prep work in advance of today's test. And man, there's the 120-meter monster.
The person just keeps getting smaller and smaller. Now, just like Falcon 9, Starship has 2 stages, which we'll talk more about those in a minute. In addition to those 2 stages, Starship actually has a 3rd stage, which we call Stage 0. It consists of all the launch pad infrastructure built around the rocket, as you can see there on your screen, and it's truly an engineering feat in its own right.
Yeah, we've got a great shot there of the various different components of it. The pad, the infrastructure, all that is required to get into filling the tanks. Now, let's talk about the Super Heavy. Its name says everything. It's super, it's heavy, it's super heavy. When it's operational, it'll be responsible for providing the power to escape that mighty gravitational pull of Earth that we've got here and take Starship into orbit.
The booster itself stands about 70 meters tall and is roughly the same height as a fully integrated Falcon 9, which is just so crazy to me. But this Super Heavy booster has a diameter roughly 2.5 times that of Falcon 9, and with 33 much larger engines. We have a beautiful view here. This is one of my favorite views that we're going to get today. Those are our 33 Raptor engines at the base of the Super Heavy booster.
Yep, and you can see they're in a couple of different rings here. So we've got the outer ring of 20 static engines. They're going to be providing a huge amount of thrust today to lift off the entire stack. But then we've got the 13 gimbaling engines in the middle, and they're going to be providing the tilt maneuvers and also helping to reorient the booster as it comes back later in today's flight.
Yeah, and when we say gimbal, it's basically tilting or almost wiggling the engines a few degrees and in either direction to allow the booster to steer itself, just as you said, Shiva.
And we'll get some great shots later of actually a wiggle test that we perform ahead of liftoff, just to make sure that all of those engines are able to control their full range of control authority.
One thing to note, those Raptor engines are completely designed and manufactured in-house. They are, as many of you know that have been following along, they are a reusable methane oxygen staged combustion type engine. So it's a lot of words there. And ultimately, that staged combustion means that we combust the propellant in stages that we kind of pre-combust them in a pre-burner. And by doing so, it allows the engine to be more efficient, i.e. more powerful.
Yeah. Now, like Falcon 9, the Super Heavy has 4 grid fins to assist with orienting itself in its return back to Earth. We got a shot of them there beneath the Starship's aft flaps. Now, as we talked about earlier, Super Heavy is not going to be attempting a land landing today. But with this flight test, we're still trying to get as much data as we can. We're focusing on the fundamental systems and operations, so that's the liftoff portion. But we are going to try to get some data on how the fins work for that water landing that Super Heavy is going to be making after ascent.
I love that great view of the fins there. Now, Starship, or the spacecraft, is the 2nd stage, and it makes up the top portion of the vehicle. It's designed for carrying passengers and cargo to Earth orbit and beyond. It stands about 50 meters tall, which is a little taller than the Statue of Liberty. It's comprised of 6 Raptor engines, 3 sea level and 3 vacuum engines, which are optimized to operate in the vacuum of space. And they provide a maximum of 258,000 tons of thrust in vacuum. Spacecraft is also outfitted with 4 flaps to help aerodynamically control the vehicle's attitude, which you can see those 2 forward flaps there on your screen now. So they help control the vehicle's attitude during atmospheric flight and enable precise landing at the intended location. Now, one thing we got to mention, the heat shields. They are iconic. Starship is wrapped in a heat shield, which is composed of 18,000 hexagonal ceramic tiles designed to insulate the vehicle during that atmospheric entry. And that's really important because the temperatures can be as high as 2,600 degrees Fahrenheit. The hex-shaped tiles, like the ones that Shiva and I have, roughly make up about 2/3 of the vehicle. We can see that we have some different shapes. Mine is slightly curved. As you can imagine, it sits on the curved portions of the Starship vehicle.
Now, the one that I've got is a hexagonal tile that's more flat, and it's really used for the flatter structures on the vehicle. And we need a heat shield because when you're coming back in from re-entry, we're going supersonic, we're compressing all the air ahead of us. That ends up causing a lot of heating along the surface, and without a heat shield, that would go straight into the structure.
Yeah, one thing that's amazing to me, especially when I first picked up one of these heat shield tiles, is that they're so light. They almost feel like they're made out of foam. They're that light, and they kind of sound like it too. And one thing that we do want to mention, in order to reject the maximum amount of heat during that entry, like Shiva was just saying, they're black, and that's because black helps reject that heat that is building up on the exterior of the heat shield.
Now, Starship is designed for vertical takeoff and landing as opposed to taking off and landing like an airplane, and that's because that's really important because we don't have runways on the moon or Mars. Fortunately, at those destinations, the gravity is not as high as it is here on Earth. On Mars, the gravity is just 1/3 of what it is here on Earth, and on the moon, it's just a sixth. So in both of those cases, Starship, with just its engines, can take off without needing the super heavy booster like we do need here on planet Earth.
Now, for today's test, Starship does not have its landing legs attached because, like we said before, it won't be returning anywhere. Starship is expected to make a very hard ocean landing, which, if we even make it that far and manage to get any views, it will certainly make for a very exciting end to today's test. At this point in time, we are 20 minutes or just over 20 minutes from liftoff. Let's check in with John Innsbrucker for a status update. Hey, John, how's it looking?
Thanks, Kate. I'm John Innsbrucker, Principal Integration Engineer here at SpaceX. We're currently loading propellant from the ground system into both the first and second stages. Now, both vehicles use the same 2 propellants. That commonality helps build the reliability. And the fuel today is liquid methane, and that's at a temperature of just over 100 kelvins. That's about minus 272 degrees below zero on the Fahrenheit scale. Now, liquid methane is a different fuel from Falcon 9. That booster uses RP1 kerosene. However, our oxidizer is liquid oxygen, and that's the same as Falcon 9. Because there is no oxygen in space to support combustion, we have to bring our own. Now, leading up to where we are right now, we had a go-no-go poll. That was conducted just after T-minus 2 hours. And once the team gave their goes, we started loading propellants onto the booster at T-minus 1 hour and 39 minutes. At T-minus 1 hour and 22 minutes, we began propellant loading of the ship. The second stage you can see on your screen right there. Now, propellant loading of the Starship's second stage main tanks completed at about the T-minus 27-minute mark, at which time we then began loading the 2 header tanks in the nose of the second stage. Now, at T-minus 3 minutes, when the first stage super heavy propellant loading completes, that means we'll have all the propellant on the rocket, and the vehicle will be fully loaded with over 10 million pounds of propellant. Now, right now, at T-minus 19 minutes and counting from liftoff, the weather and winds are looking good. We have been watching the ground level winds. They're at 18 miles an hour. As the morning continues, they will increase, but that is below our limits right now. We're also looking at upper altitude winds. We're waiting for one more balloon, but we believe that we're going to be go. On the launch vehicle itself, the teams, the good news, they're not working any issues right now. But if for some reason we do not make our test flight today, if we have to hold, We have a backup launch window. However, we're not sure when it would be. It could be 24 or 48 hours after today. It'll depend on how far we get into the countdown. But right now, heading for a T0 at 8:28 Central, 13:28 Universal Time. Kate, everything is looking good.
Awesome news. Now, in order to make life multiplanetary, we need a fully reusable vehicle that's capable of carrying a huge amount of cargo and a lot of people to orbit and have a pretty quick turnaround. The idea is to effectively reuse launch vehicles just like airplanes.
Yeah, imagine if you had to wait for a new airplane to be constructed every time you wanted to fly. You'd rarely go anywhere, and for most of us, it would be completely unaffordable. In order for us to get to Mars and back with lots of people, lots of cargo, multiple times, reusability really is a must.
In advance of our first missions to Mars, Starship will execute a number of missions with both cargo and people, starting with Earth orbit and eventually expanding to the Moon and beyond.
Now, in the near term and a bit closer to home, Starship will also be critical to other programs. Once fully operational, it'll deliver the full-size and upgraded version of our Starlink satellites. And that's super exciting because our next generation satellites represent a step forward in Starlink's capabilities and will allow us to connect millions of more people around the world with high-speed internet to watch launch webcasts.
Such an exciting future ahead of us. But first, let's talk a little about how we got to where we are today.
Now, Starship's testing ramped up in July of 2019 with our Starhopper prototype, sort of a short version of the Starship that we see today. There's a great photo of it. It was just over 18 meters tall. It had a single Raptor engine, and we had it to test fly and perform low-level altitude maneuvers and attempt landing. The initial test flight, or hop, reached about 20 meters in altitude. That was followed by the one that you've got on your screen here. This was our 150-meter altitude hop. We went up, took a little jaunt away, about 100 meters or so away from the launch pad, used that Raptor engine to fly and actually land. And actually, this hopper is actually down at Starbase now.
Yeah, I love this shot. It's just so fun to see it fly. After a series of 150-meter hop tests with earlier prototypes, the Starship program saw a major breakthrough during a test flight of the vehicle known as serial number 8, or SN8. You can see it there on your screen now. In December 2020, SN8 demonstrated a first-of-its-kind controlled aerodynamic descent and landing flip maneuver. 2 words, belly flop. The SN8 prototype rose to an altitude of 12.5 kilometers or 7.8 miles and conducted a belly flop maneuver, which you see there, during its descent. While it didn't stick the landing, the test was a major milestone in the development of Starship. In fact, we should be able to see that unfortunately failed landing. Boom. It was fun to watch, though.
Rapid unscheduled disassembly, but learned a lot of data. Now, the testing continued on to prototype serial number 9. It took a 10-kilometer flight. That's about 6.2 miles up. In February of 2021, we had a nominal ascent. We executed the engine cutoffs once we got to the top of the altitude window. We did that belly flop maneuver, which is so much more fun to say than controlled descent, aerodynamic maneuver. That was all stable, but unfortunately, we had a dramatic end on this flight as well. We had a failure on one of the engines that resulted in another pretty large fireball. But what was really cool about both of those flights was how much we learned just between serial numbers 8 and 9 and how quickly we were able to achieve our primary objectives in those 2 flights. In addition to that, we got so much data that demonstrated control of the vehicle in that subsonic regime.
Ultimately, we performed 9 Starship high-altitude test flights in total. And then, as you see on your screen there, in May of 2021, SN15 launched from Starbase, reached an altitude of about 10 kilometers, performed a number of maneuvers, and safely returned to the launch site. This was the first Starship prototype to fly, control its descent, safely land, and be recovered in one piece.
And people were cheering like crazy
I was
after
one of
that
them.
test flight. Now, having achieved those successes in our suborbital campaign, one of the next big challenges is for the upper stage when it comes to reusability and surviving the hypersonic, really high heating phase of entry. Combined with the later ability to refill Starship's tank with propellants, the fuel and oxygen, while we're on orbit, that will enable us to have a fully reusable transportation system that's designed to carry both crew and cargo on long duration missions, interplanetary flights, and will help humanity get to the moon, travel to Mars, and beyond in our solar system.
This is all just basically our path of progress, basically an iteration on each vehicle. And that iterative process is a core part of how we work here at SpaceX. We like to test early and often, publicly as well in our case, and that's both for hardware and software. And while it doesn't always go as expected, we learn so much from it, and it informs our next attempt.
Yeah, we learn a lot from actually putting the vehicle through flight-like tests. Even the test on Monday gave us an opportunity to learn more about the vehicle into today's launch attempt, and so far things are looking really good. Now, we are continuing into our countdown. We're about T-minus 12 minutes to go. I think it's a perfect time for another check-in with John Insprecher. How's it going, John?
Well, Shiva, the good news is that the nets are quiet. The teams are currently working. No significant launch vehicle issues. You can see the T clock there on your screen, T-minus 12 minutes, 10 seconds, and counting. Propellant loading is continuing on both the Super Heavy and the ship stages. You can see the graphic on the left-hand side of the screen. Most recently, we began loading liquid oxygen and liquid methane fuel into the header tanks on Starship. Those are two small tanks just underneath the nose of the second stage. Now that started at T-minus 27 minutes. That'll be wrapping up at about T-minus 9 minutes. Now the Starship second stage main fuel and LOX tanks are loaded for flight right now. The Super Heavy first stage booster propellant loading is continuing, and that'll go till about T-minus 3 minutes. We're underway with engine chill as we get ready for T0, and we're also configuring the launch pad for liftoff. The booster hold downs have been unlatched. They'll be ready to retract at liftoff, and the second stage quick disconnect is beginning its configuration for release. The methane and liquid oxygen propellants currently going to the second stage go through that quick disconnect. That's that arm that reaches out from the tower to the base of the second stage. The SpaceX team continues to check in with the Coast Guard. Good news is we've not heard any reports of boats in the safety perimeter as the launch vehicle heads out over the Gulf of Mexico. So right now, T-minus 10 minutes, 40 seconds, and counting. Everything continues to go well for an on-time launch.
Now, today's test flight is taking place out of our Starbase facility in South Texas, and that test site has gone through a huge amount of development over the last couple of years.
One thing I want to point out, this is a great view from our drone. Not only can we see the pad, but in the fog, kind of in the distance, in the background and to the left of the pad, you can actually see our production facility, which is the other part of Starbase in addition to the launch pad.
Of course, as part of rapidly iterating with our test program, we're also rapidly iterating on our production system to produce Starships and Super Heavies. Last year, the Starbase team produced 4 Starship Super Heavy boosters and 5 Starships, along with their 200th Raptor 2 engine, and they're only scaling up from there, Kate.
Yeah, it's incredible to think that for 2023, production has 5 boosters and 8 Starships going. So it's incredible. And it's important to have that system fill in basically the manufacturing line so that we have product ready to go as soon as we're done with this test.
Yeah, exactly. And ultimately, I mean, we talked about how Starship is an order of magnitude more payload to orbit. But if you're going to go set up a base on the moon or Mars, you're going to need thousands of metric tons of propellants. And so you're going to need a fleet of vehicles that's capable of doing that.
Yeah, one thing to note, Starbase directly employs more than 1,800 employees. It's the largest employer in the area, in fact. And we're very thankful to Cameron County for being so supportive. This is a view from the Cameron County Amphitheater. And there's a crowd there, and you could tell by the energy here in Hawthorne as well that everyone's getting really exciting. I feel my own heart rate going up and up.
I know. It must be really, really exciting to go see this. And I mean, just the sheer amount of power on Starship, you're going to feel it down there when this thing lifts off from the pad. We've actually got a great shot here of the natural surroundings around the pad. Oddly enough, most of the pads end up being around sort of wild locations like this. But coming up on T-minus 8 minutes, I think it's another good time for check-in with John.
Thank you, Shiva. T-minus just over 8 minutes to the first test flight of Starship. Currently, we are pressurizing second stage. We are also closing out liquid oxygen and fuel header loads on the second stage. We're also getting ready for propellant load tank pressurization on the first stage. In fact, we are just now closing out header tank load on the second stage. Now with the header tanks loaded and closed out, that means we're down to just the first stage to finish loading. That'll finish about T-minus 3 minutes. And at that point, when both stages are loaded, we will have the 10 million pounds of liquid propellant on board. Now in the next few minutes, the guidance system will begin its final alignment for flight during a quiet period when the rocket's not doing anything. The automated flight termination system will be armed, and a final TVC checkout will be performed. Those are the engine wiggles, and hopefully we'll be able to see that with the cameras underneath the vehicle and maybe even the second stage engines. And there's a view looking underneath the super heavy first stage with the 33 Raptor engines. Now a reminder as we continue counting down, if we do need to hold, the point where we hold the clock would be at T-minus 40 seconds. We can pause there. Typically in the past, if we need a little bit more time to finish final checkouts or do some pressurization of the onboard storage tanks, that's where we would hold. But currently we're not hearing a need to hold, so at 6 minutes, 27 seconds, everything looks good. And of course, Kate, Shiva, as we get close, we're going to get into the engine ignition sequence of 33 Raptors, and that's going to be something new for everybody.
I cannot wait for that moment. So for those of you that are familiar with how we launch Falcon 9 rockets, you probably know that we light all 9 of those first stage Merlin 1D engines all at once. It's pretty different than what we do, or what we're attempting to do today. We're actually going to be igniting those 33 engines in banks or clusters, and that sequence starts at T-minus 6 seconds.
Yeah, and the ignition sequence is a little bit different, both in terms of the timing and also the ignition method. So on Falcon 9, we use a chemical called T-tab. It's a pyrophoric material, so that means when you mix the two together, it produces a flame that kicks off that green characteristic spark on Falcon 9 missions. But actually on Starship, we use electrical ignition systems. Many of those are integrated on the ground system here. And the electrical ignition, we start lighting the banks at T-minus 6 seconds, and then over the next 4 seconds, the 3 sets of banks will ignite and eventually bring the booster up to a thrust to weight greater than 1 and hopefully ascent.
Super exciting. Like we said, pretty different from our Falcon 9 launches, and so this will be the first time that any of us have gotten to see this type of integrated test flight with both the Starship and the Super Heavy booster.
Everyone's cheering as we get into T-minus 5 minutes.
We want to remind everyone that success today is anything.
Yeah, it looks fun down there. I kind of want to go join them.
For today, success is anything that we learn that helps improve the future builds of Starship. If we lift off and clear the pad, we're calling that a win.
A great shot of the pad there. A great shot of the quick disconnect on the second stage. You can see the frost line on the booster where that methane is fully topped up. I think we're just coming up on the last few minutes here of propellant fill on the booster. Now that quick disconnect is going to separate away as we actually get into the ignition sequence, but it's providing electrical connections now and also providing the propellants that we're loading into the vehicle.
Yeah. We're just now under 4 minutes until liftoff of the Starship flight test. We've been following along for what honestly seems like days and days now, but really it kind of comes down to years. It has been a long time to get to where we are today. Now, fast forwarding a little bit, we have the opportunity to hold, if necessary, at 40 seconds, and we are able to hold there for about 15 minutes or up to 15 minutes and still be able to lift off.
Yeah, and that's a little bit different from Falcon for the propellant sequence on Falcon that we don't have the opportunity to hold. So that's a cool new capability on Starship.
Yep. Right now, T-minus 3 minutes, 10 seconds and counting. We got some great views from the drone. It's nice that the fog is slowly lifting. We get some of the blue skies, hopefully good views. What we're waiting for right now is closeout of propellant loading on the first stage. That should be wrapping up here shortly. In fact, it looks like fuel fill and drain valves are coming closed. That means first stage is fully loaded, second stage fully loaded, and that 10 million pounds of propellant on board the Starship launch vehicle.
I want to take a quick moment to say that the crowd energy here is electric. I feel like it's Falcon Heavy test demo all over again.
And hopefully you'll hear us as we get into the plus count. But right now, next activity is coming up. The flight termination system arms at T-minus 2 minutes. Thrust vector control checkouts at T-minus 2 minutes. And then after that, major activity will be the T-minus 40-second gate. There's a view looking up at the 33 Raptor engines. There are 20 engines in a circle on the outside, and as Shiva said earlier, 13 engines on the center. Those are the ones that gimbal and steer the vehicle.
I don't think I've ever seen someone so excited for TVC wiggles.
Love this view. These are the 33 Raptor engines at the base of the super heavy booster. I think we can see those wiggles now.
We're currently inside 90 seconds. Next major activity, T-minus 40 seconds. That is a gate, a decision point. We're waiting. Possibility the propulsion team may need a few minutes. Flight termination system is armed for flight. We're getting ready for T-minus 1 minute and counting. No, T-minus 1 minute and counting. Next, we'll see as we get past T-minus 40 seconds for final checks of the vehicle. Okay, you can see the clock is recycled. Flight director has called a hold. We are recycling. For the moment, we'll see where they move the clock back to. They could hold at T-minus 40 seconds. They could go to an earlier point. Give us a minute to listen into the nets, and we'll see if we can get you more information to share. John Innsbrucker again here at the Hawthorne webcast desk. We're holding a T-minus 40 seconds. What we've heard so far is we have a couple of issues we're working. One is the booster tank pressurization. Final pressurization was just a little bit long. That's not unusual. We've held at T-minus 40 seconds before to pressurize. That appears to have been resolved. At the same time on the second stage, they're working some final purging. We should know very shortly if that is cleared and if we'll continue the countdown.
Everyone, especially that person, is excited to keep going. Like John said, we should know shortly if we are able to continue. But as we mentioned before, we are able to hold up to 15 minutes and still be able to lift off today.
Yeah, on Falcon 9, it's a little bit different. Once we start propellant loading, we pretty much have to go at the targeted time. Otherwise, the propellants can warm up and we may not have the performance for that particular mission profile. It's a little bit different on Starship.
Folks, if I can interrupt, it looks like they're clearing all the flags, and we're going to release at T-minus 40 seconds.
That is amazing news.
Amazing.
Team working quickly through their issues on first and second stages.
And I'm sure all of the rehearsals and simulations that they've been doing have prepared them to evaluate this data quickly to try to get us in for today's launch attempt.
For those of you just joining, we have a brief hold at the T-minus 40 second mark. The team is resolving one issue with the bleed purge on the stage 2 Raptors. Like John just said, the teams are quickly working that, and it looks like the flags are being cleared as we speak. So we should be able to resume the launch countdown any moment now.
And it's worth noting on Starship that once we resume the countdown, it restarts from the 40-second period, and then we keep going unless another condition pops up. So stick around because Starship could be going here real soon.
Don't walk away, that's for sure. Amazing views here coming to us from Starbase, Texas.
Cheering to close the start again.
T-minus 15 seconds. 10, 9, 8, 7, 6, 5, 3, 2. Booster chamber pressure is nominal.
43 seconds into the test flight of the inaugural Starship vehicle. Tower cleared, we're into pitch over. Propulsion reports first stage engines nominal. What a sight from the ground cameras at Starbase. We're flying at twice the thrust of the Saturn V heading to space.
Acquisition of signal, surface proceed.
We're throttled down and throttled back up. Going through the period of maximum aerodynamic pressure. As the velocity increases, the density of the atmosphere is decreasing.
Max Q.
Lessening stress on the vehicle. The call out, max Q now. Continuing to watch the first stage as we head down range. A 100 seconds into flight. Our next major activity is going to be shutdown of the first stage. The Houston tracking station now acquiring the vehicle. With shutdown, we will get separation of Starship from Super Heavy and ignition of the Starship engines. When Starship separates, we light up 6 engines in a staggered sequence, If all goes well, those 6 engines will burn for almost 6.5 minutes. Onboard view from Starship. And there's views of the Raptor engines on the second stage as we prepare for stage separation. Now, after stage separation, the first stage will flip and begin a boost back maneuver for landing in the Gulf. Continuing to fly, 2 minutes 40 seconds. Let's get ready for main engine cutoff.
Booster engine cutoff.
Beginning the flip for stage separation.
As of right now, we are awaiting stage separation, where Starship should separate from the Super Heavy booster.
Yeah, Kate, right now it looks like we saw the start of the flip, but obviously we're seeing from the ground cameras the entire Starship stack continuing to rotate. We should have had separation by now. Obviously, this is does not appear to be a nominal situation.
Yeah, it does appear to be spinning, but I do want to remind everyone that everything after clearing the tower was icing on the cake. And there, as you saw, as we promised, an exciting end to the Starship inaugural integrated test flight.
Absolutely pumped to clear the pad and make it this far into the test flight, the first integrated flight of the booster and the Starship vehicle.
Live view there of our control center at Starbase, which we refer to as Star Command. As we said before, obviously we wanted to make it all the way through, but to get this far, honestly, is amazing.
Well, if you're just joining us, Starship just experienced what we call a rapid unscheduled disassembly, or a RUD, during ascent. But now this was a development test. This is the first test flight of Starship, and the goal was to gather the data, and as we said, clear the pad and get ready to go again. So you never know exactly what's going to happen, but as we promised, excitement is guaranteed. And Starship gave us a rather spectacular end to what was truly an incredible test thus far.
Now, as we mentioned at the start of today's program, any and all the data that we collected during the test is going to help us with further development of Starship, and it's going to improve the vehicle's reliability as SpaceX seeks to make life multiplanetary. It's really worth noting that the flight path was designed to be over water and all the air and sea space. Along with that flight path and those surrounding areas were cleared in advance of the test. And of course, we're going to be coordinating with local authorities for the recovery operations.
But honestly, what an exciting morning. Oh my gosh. We had a successful liftoff from Starbase, Texas at 8:28 a.m. Central Time. We cleared the tower, which honestly was our only hope. We cleared the tower, and all the data that we collected all the way through all those Raptor, those 33, although I think we saw that 3 Raptor engines were out. But we got all that data, and we got so far as to hoping to see the Starship, the second stage, separate from the first stage, the Super Heavy booster. And unfortunately, we didn't make that happen, but that's okay. It was the first integrated launch, and honestly, today was amazing.
Absolutely incredible day. We made it through a number of those initial test objectives with getting booster ascent, getting all the way through the countdown, working some issues at the end. Like, totally really fantastic day.
Got through the gate at T-minus 40 seconds on the second try. everything released, the hold downs, the quick disconnect arms,
Yeah.
everything moves out of the way. And then we got the vehicle off of the pad through max Q all the way up to stage separation, even starting into the prep for stage sep. And then, as we say, a lot of excitement.
Yep. Honestly, my face has had a smile on it since liftoff, and now my face hurts. Now, since we don't have any insights on the cause of our rapid unscheduled disassembly at this point, we're going to end our webcast here. Teams will continue to review the data and work toward our next flight test. But before we go, a big congrats to the entire SpaceX team on an exciting first integrated flight test of Starship. And of course, a shout out to our viewers. We appreciate you joining us. And as always, we thank you for your interest in Starship, SpaceX, and your ongoing support. Till next time.